last week we were given an interesting challenge. We had to build a collaborative editor using TipTap with real-time editing support. But the catch was we couldn't change or break our existing Django app, which is running on WSGI. And as you probably know, WSGI doesn't support WebSockets. So we had to find a workaround. So instead of forcing WebSockets into Django, we built a completely separate service, a dedicated collaboration server just to handle a real-time communication. So like I mentioned, we created a Node.js collaborative server, which is dedicated server. So here there is one challenge over here, which is authentication, because user is logged in with the Django backend server. So how Node.js server knows that user is already logged in with Django backend server? So over here, with the help of this diagram, I will explain you how we can solve this problem. So first of all, I will explain you how our current LOS authentication system works. So let's suppose user open the LOS website and send a request for login. So Django backend server will shows the login page and user will enter the creds and Django server will validate the creds and send one HTTP only cookie which contains session ID and other user information. So this HTTP only cookie is a special kind of cookie which is only accessed by Django backend server, not by client. Client can easily see that cookie in their memory section, but they cannot access that or delete that cookie. So this is the one part. So we can jump to the next part now. So let's suppose user will reach till credit memo task and open the TipTap editor. So over here, UI will again make a request to Django server for JWT token. Now Django will create one JWT token which contain all the information about the user, like tenant ID, user permissions, and all other necessary user information which we required in collaboration server. So and Django will send this token to the UI. Now UI will again make a WebSocket request to a collaboration server with this JWT token and the document name which user want to visit or edit. So when the user will make a JWT token WebSocket request, now collaboration server will validate this token and extract all the information. If it is a valid token, then the connection between user and collaboration server will established. So in this way, we can authenticate the user with collaboration server using JWT token validation. So JWT token is a special kind of token and which use crypto hashing. So it is very secure, and the way we are using in our platform is also very secure. I will explain you how we are using this mechanism in our collaboration server and authenticate the user as well. So let's jump to the demo part now. So first of all, I will spin up the server. So we containerize whole the application using Docker. So we have two commands, one is make build and other one is make run. So with the help of make build command, we can build all the files, and with the help of make run, we can spin up the containers. So when I just hit make run command, you will see it is pulling. So it's actually the initial call. So it is pulling the Redis image. So as you see, the Redis image is pulled. Now the Redis container is pinned up. So I also show you the Docker daemon over here. As you see, the Redis is up and running, but the backend and frontend containers are still try to spin up. Okay, we will wait. Yeah, so as you see, it is now the backend server and the frontend server is up and running. So the backend server is uses Node.js, and front-end server is used React.js, and backend server is running on the port 3000 and front-end is running on 3001, and Redis is up and running on the default port, which is 6379. So now I will open the Chrome browser and hit the URL. So as you see, I hit the front end URL with port 3001. So this is the authentication page. So this is only for the demo purposes. So we created this page, but in real life, this page is not there because UI will make a WebSocket request along with the document name and JWT token. So I will also open the network tab over here so you can understand it better when I make a request. So when I just type this document name, I type a document name over here, Vihan new, and JWT token. So I used some dummy users. So this user one has a read and write permission. So when I click login, so you will see over here there is one request in network tab. This is a WebSocket request. As I mentioned earlier, so UI will make a WebSocket request along with the document name or document ID, which is unique, and that this is a JWT token for that user, which contain all the necessary information which is required for collaboration server. So over here you will see this is not a JWT token because we encoded this in a form of base64, and WireSocket will again encrypt this base64 and then send it to the collaboration server. So it provides the extra layer of security over here when we are passing this token to the collaboration server. So now as you see over here, document name is Vihan new, the user is user1, and the permission is read write. The connected user is only one, and this is the technical details. This is the WebSocket URL which is currently up and running, and this is the protocol which we are using. So if I write anything over here like Singla, so currently on the one user is connected with this document. Let me open one incognito mode and just type this URL again. So I will open this editor with the same document name, and now at this time I'm using the user 2, which also have read and write access. So when I click on login, you will see that the text which I wrote over the user 1 editor, it is also visible over here as well. So user 2 has read and write access, so they can also write anything or edit anything. So you will see the real-time cursor collaboration is also there. So if I select anything on a real time, user 1 will also see everything. So if I can write anything over here, as you see, everything is coming real time. If I just select anything from here and open the same tab again, you will see the user 1 is selecting this part, so it is visible over here as well. So in this way, the real-time mechanism work with TipTap editor. So we built all the things from scratch, and we create a separate dedicated server. So we also do a lot of optimization work over here. So earlier, what we had done is, like if I type anything like THIS, so in every keystroke they will so this editor will make a request to the collaboration server, and the collaboration server will broadcast to the other users which are connected with the same document. But this will take a lot of bandwidth of the server. If multiple documents are connected with the server and multiple users are working on the different documents, then it will consume a lot of bandwidth of the server. So that is why we implemented debouncing. So with the help of debouncing, the load from the server will reduce by 80%. So we just give a 300 or 400 millisecond debouncing. That really works well and optimize the system very well as well. So this is a whole demonstration part of our current working website. And now I move to the system design. Why we use Redis, and if multiple users are coming, let's suppose if 100 user are connected with our server and they are working on different documents, and how we can scale our architecture. So how Redis work in this scenarios. So let's suppose we have 4 users which are working on a same document. So we have 2 servers. This is the Node.js server and this is a Redis stack. So this is a master Redis and this is a child Redis task. So master will broadcast all the message to the child, and child will broadcast to the server too. So in this case, this Redis cluster works. So I will explain you how the things really work from the very start. So let's suppose browser 3 and browser 1 will try to open TipTap editor. So UI will make a WebSocket request along with JWT token. The request goes to load balancer, and load balancer distribute the traffic on YJS server 1 and YJS server 2. So let's suppose browser 3 and browser 1 is connected via server 1, and browser 2 and browser 4 is connected via server 2. Now let's suppose browser 1 types something on that document. So the request goes to server 1 because it is connected via server 1, and server 1 will broadcast that message to browser 3 because browser 3 is directly connected with YJS server 1, but these two users are connected with server 2. So here the Redis comes. So Redis will act as a broker. So YJS server 1 will broadcast the message or publish the message to the Redis server, and Redis server will broadcast the message to YJS server 2, and then YJS server 2 checks that the document which Redis broadcast, is there any user which are connected with this same document. If yes, then it will broadcast the message to browser 2 and browser 4 as well. In this way our whole architecture work. And if let's suppose in future there are 4 more users come, and so we can directly spin up one more server which are also connected using Redis. If 2 users are connected with the server 3, then the same thing happens for that as well. So in this way our whole architecture works over here. Hope you will understand this. Now I will again go to the same editor. So now I will also show you the permissions part. So let's suppose I will open the Brave browser, which is let's suppose a new user. So I will open the same document, but in this time the user has only a read permission. So if I open this document, so user only read this document, they has no any access for edit or delete anything. So in this way the things work over here. Hope you will understand this small demo. Thank you so much for listening this.